evening and welcome once again to Tinker Tailor's Solar Fry, the Let's Try program here on the mighty Loading Ready Run Video Entertainment Network. My name is Ian Horner, and I will be your navigator through tonight's activities. But before we get started, we of course want to remind you that nothing that we do here at Loading Ready Run would be possible or even have a point were it not for you, the viewer, especially those of you over at patreon.com/loadingreadyrun. You keep the lights on. You keep the water flowing. You also keep the water flowing in the other direction out of the building. It's important to have both, but you make it happen. So thank you so much, and cheers to you. Also, speaking of water moving in and out of places, we're moving to a different place that will also have those same requirements for water. So if you'd like to be a part of the move to Moonbase Mark 6, go check out store.loadingreadyrun.com or lrr.cc/mkvi, I believe, and you can help us out by picking up some special limited edition merch, which is currently available for pre-sale. So get your orders in now. Run, don't walk to your computer, and then type fast, but accurately, lrr.cc/mkvi. So, what do we got here today on the channel for a Let's Try? Well, a couple of projects that I've had in my back pocket for quite a while that I'm very excited to finally get out here today. And this is probably one of this is one of those Tinker Tailors for the books, because we're bringing out all the old favorites. We're bringing out an ESP8266 to flash up with new and fun software. We're going to be doing a bit of soldering and probably fixing some new microcontrollers. And we're going to be working with some ancient tech, which was recently rescued out of the trash. Like this guy here.
For rescued out of the trash for the second time.
Yes.
Because I believe Graham rescued that. I think we just got that at like Value Village, like maybe 15 years ago.
Oh God, yeah. this has been in the prop room in the technology box for as long as I've been working for this company.
Yeah.
And it's as far as I knew, it had never been turned on. I'd ask people they were always, does that thing even work? And the thing is, when you provide it with the appropriate voltage, it actually does. Or at least it shows you a bunch of static, because unfortunately, as it turns out, analog broadcast ceased years ago. So there is currently nothing on the airwaves that this will be able to tune into. But God willing, God, or I guess electrons willing, we're going to change all that today. We're going to cause an ESP8266 to broadcast on channel 3 to this TV. Now, some of you who are fans of hardware hacking sites may have run into this particular thing before. This is a project that was originally put together by Knollhor, or CNLOHR on GitHub, and this is their channel 3 piece of software. Because as it turns out, one of the features of the ESP8266, and specifically the ESP8266, is that it has the ability to run its I2S bus shift at 80 megahertz. Now, why is it important that it's at 80 megahertz? Because that's due to a lot of math that you can actually look up on the Channel 3 repository. They break down all the information that you need to know about how this is actually working. But 80 megahertz is divisible by the frequency needed to get a frequency into what is known as Channel 3 on the NTSC spectrum.
So a faster microcontroller or a slower microcontroller would not work for this. It's actually just a coincidence that the ESP8266 happens to run at the right.
Correct.
Wow.
And it's got it's that it's able to run that fast, and also that it has on board its own little DAC, a digital to analog converter, which then takes the information that we're feeding it through the I2S bus, which is a high-speed sound-based bus usually, shoving it into the DAC to go from digital to an analog signal, and then shoving that signal to a pin on the 8266, which you attach an antenna to, and it fires off video. Somehow. Random Trivia's got the GitHub repository there in the chat if you'd like to follow along. And yeah, it's quite a fascinating little thing. If you go through oh no, wait, that's right. That's for Project 2, where they go into some more information. But once we get this set up, we'll be able to actually see a little bit more about what's actually going on in the microcontroller to actually make the thing go. Not sure if the vertical roll is correct or if it's the rate of the camera. Yeah, no, that's camera rate, I believe. There. Good.
Oh,
good.
interesting.
Good catch, Wedge. Actually, you know what?
I can actually. Let me mess around. I can adjust that remote.
Ooh. I mean, I've also got vertical hold.
But I can adjust the shutter speed of the camera.
Oh no.
For those of you who haven't worked with cameras and CRT monitors, this used to be a real pain in the patootie.
Oh yeah. This is fun.
There's a certain wait. Let me just. I mean, we're going to go way too dark here. Notice now we're actually hitting the refresh rate of the LCD behind you, and also the LED.
Wow. Yep. No, here we go. You can see the
LED lights that are lighting you.
Yeah, the shutters. Oh my. Yes.
All right. It turns out 1/2000th is not the speed we need.
I think there may also be some vertical hold issues there too.
Anyway,
I
so we may I don't know. We may have to. We may not get an amazing picture on the cameras. We'll have to see how that
Yeah.
goes.
Well, first of all, we've got to get some signal into there, which means we're going to need to do a couple of things. We're going to need to get ourselves a microcontroller, and thankfully, of the ESP8266s that I have ordered in the past, I had one left that is either in my possession or still functioning. Kids, don't connect a lithium polymer battery directly to one of these. You will let out some magic smoke.
Oh, no.
Yeah, that's what happened to one of the Desert Bus buttons this year. But this is our last one, and yeah, pretty simple. Nothing we need to do to that other than attach a pin or attach a piece of wire to the pin that we're going to use as the antenna. And I'm just going to do that with a little push-through hole wire, but I need to remember which pin it is. Aha! GPIO3/RX. So I guess it's just the RX pin. All right. So let's get ourselves a little bit of wire here. Aha.
And does the particular wire you use matter?
No, not at all.
I guess, considering we're attempting to broadcast 1 foot.
Exactly. Yeah. If we're, this is not going to be an episode that is going to include a course on antenna design. That, as well, will be left as an exercise to the viewer. Just want to see if I've got any DuPonts that I've already split open for this reason. No? Okay, great. We'll just take a, let's see, we want an extender, if I believe. Brown seems like a good color for that. That's also not the kind we want. All right, let's just take one off of here. Good. Yellow it is. Whoop. And then let's just put that through the hole there on the RX side. Boot up the soldering iron. And we'll get some flux on there. People are asking, would I like a handbook on antenna design? No, but thank you for the offer. Antenna design is one of those things that I briefly dabbled with back in the mid-2000s, back when everyone was going gaga over the latest thing that you could attach to your WRT-54G, the Pringles Cantenna.
Oh, yes, the Pringles can was a big deal. Yeah, yes. Using Pringles can as a directional antenna.
Yep. And of course, the WRT54G being incredibly hackable on its own. You would get people trying to bridge the gap between your house and your neighbors across the way. Or the old, did anyone else out there do any war driving during that era? 'Cause I remember that. I thought that was going to be the coolest thing. We could find open Wi-Fi and just get free internet.
I mean, I wouldn't call it war driving, but, setting up somewhere and hoping there's free internet around is still definitely a thing.
It's a time-honored tradition, yeah.
Luckily, I mean, these days things tend to be a little bit more, you can go into like a Starbucks or something and
A little bit more formalized.
yeah.
Okay, and just because, let's add a bit more.
Like connecting to random Wi-Fi links in like the airport or whatever to try to like eke out a little bit of internet before you have to jump on your plane is certainly something I've done on many occasions.
Let me tell you, the need to refresh those podcasts before the flight starts is real.
Or download a couple of maps or something.
Yeah. Okay. I mean, more often than not, it's just download the instructions on how to get your new SIM card for the next country before you go to the next country. All right. So, the other issue to this particular installation is that it doesn't use the usual programming interface. Usually, every time I've been on this show so far doing a burn of one of these little guys, we've been going ahead and just using the Arduino interface to log in and write your code to it. But this system uses a little bit more complicated of a tool chain, which in this particular instance, because it hasn't been significantly updated in years, in fact the project appears to be 8 years old, you're going to need to get Python 2 running. So good luck. That's...
Wow, I didn't realize the ESP 8266 was that old. I thought this was like something people had recently figured out with this thing.
Yeah, no, it's an old code, but it checks out. It's probably something that could be updated to newer tool chains, but the maintainer hasn't really done anything to it.
I guess it's not like NTSC has changed in the last 8 years.
No. In fact, it's a relatively I'd say it's in maintenance mode right now.
Whatever you call it when you aren't maintaining a thing in maintenance mode.
Yeah. That said, as a person who doesn't hate the terminal, once you get the tool chain actually set up, you'll also need to use WSL, the Windows subsystem for Linux 1, not 2, 1, because again, legacy code. But once you've got it set up, it's actually quite an easy system. And if we can bring up the laptop here, let me just push that to the side or push that down so I'm not hiding my own prompt. Once you've got it all set up, it really is incredibly easy to get things into the machine. It's just done using a make command, which gives you a lot of options to automate the process of burning it, burning the ROM, bringing up a console, erasing the whole system. This is actually just very good as a troubleshooting system for ESPs, and just a good tool chain for making your own projects as well.
So it's always great to have when there's options that are like, will probably change. So I guess they didn't. If this happened 8 years ago, I guess they didn't change.
So we'll still have to use some of the tried and true tools here. So we'll have to go to the device manager because we're gonna have to find out what COM port this little dude is going to be on. So let's plug it in, and let's have a look here already.
Also, more utilities should have a burn it all function.
Yes. What do we got in COM? We've got our active memory technology. I don't like that ever. We've got USB serial COM 5. So that's good. Let's just double check to make sure that's the case. Unplug. Plug it back in. COM5 it is. Okay. So that being the case, we're going to have to, we're going to burn, no, we're going to make, and then we're going to burn. Yeah, make burn. And, okay, right, because we have to specify the port. So, port equals /dev /TTYS4, and then make burn.
I have not used subsystem. Says it needs ESP root.
Yeah, and it also needs port 5.
I've not used Windows subsystem for Linux too much. It seems like it's a neat way of having that, if you need to drop into Linux to do something, and then it's almost like a Mac, the OS 10 thing where it's like, okay, let me just drop into the command line and fix this.
Yeah, the weird thing about it, though, is the way you bring it up is not by bringing up a terminal and then going over into what you need. You launch it by going into your start menu and typing Linux, or rather, in this case, Ubuntu. And now we're in Ubuntu. Woo! Toppy. Gee, what is running there?
It's sort of sandboxed from the rest of the system, though. Eh?
Yeah, exactly.
Like you aren't seeing the processes that the actual Windows side is running.
No, certainly not in there. And I'm not even sure. ls/. Yeah, I'm not even sure how you touch the actual Windows system in terms of the file system. I've just kind of been keeping the two worlds separate for a while. Alt-F, no. Let's just close that up. Okay, so things have been written. Let's give it a reset, as is tradition. And ideally, we should see a new wireless network show up.
It's got the sort of bootstrap setup.
Yeah.
Remember.
Aha! ESP. That's our friend. You can do it. I believe in you. Okay, well, the thing is working. Let's just double check here. Let's bring up a console in our Arduino here, in our serial monitor, and just see what's COM4. Right, we need to move that over to COM5.
I don't think there's any wireless networks there that reveal where the moon base is, but maybe.
No. I know one of them is actually the government of British Columbia's public network name. And
yeah, as well, yeah. Anybody watching not from the area and who's like, oh ho, I see that Shaw Open is near you. That must mean you might be near the Shaws.
Good luck.
That does not help you.
No.
Also, TELUS does not help you.
No.
You're seeing a lot of default router named networks.
Okay, so we got DHCP server start. IP is 192, and we, I think, have joined the network at least. Yep, we're on the network, so we just need to connect to this IP address. Boop, and boop, and boop, and boop. Right, you're not going to be able to see that because...
oh, right, you just dropped off the network.
Yes!
Right.
All right, well, I'll turn the screen around once it actually loads up, but it does appear to be working. It's just very slow. Transferring data. Okay, well, while we wait for that to figure its life out, let's actually see if it's doing what it's supposed to here in terms of the signal.
Should we already be seeing something?
We should, if it's currently, because it should boot directly into its own image test loop.
Oh, wow.
So let's see if we can find where. Let's extend the aerial.
Oh, yeah. Get the bunny ears going.
Yeah. And see if I can...
Should be channel 3, right? Oh, wait.
This is already great.
Whoa. It should be channel 3, though. Isn't that way up at the other end of the...
No, it's yeah, I guess it is all the way down there. So let's see.
Hey!
Oh, that's a solid lock, friends.
Oh.
Let's adjust the vertical hold then.
Holy crap.
That's a lot cleaner than... Where'd it go?
You all saw it.
There we go. So... And this is all just coming over a fully unconnected wire.
I don't mean to sound skeptical of your hacking prowess, but I have to say I was a little... it was more that I was concerned that this monitor just like didn't work.
I mean, I think the monitor may have some issues of its own. Oh god.
Whoa!
These
It's running through a test.
Right.
Holy crap!
Matrix-based 3D.
Now
engine.
is this a color signal coming through that is
It
being
is.
interpreted in black and white?
It is indeed.
Whoa!
Yeah, it's amazing that these little microcontrollers have this much power in them when you optimize the heck out of them.
This is like some demo scene stuff going on right now.
Yeah, I'm very impressed. But we have, in addition to this working,
This is like one of those like YTV bumpers.
we've also got the introduction. So let's just grab ourselves.
Right, we can't use the NDI right now. Oh wait, no, yeah we can. It is now back connected.
Oh, is it? Oh, well, that's weird. Let's hit NTSC.
Wait, should it not be connected?
Yeah, it should not be connected. We should be connected to the ESP still.
Huh. Interesting.
Sorry about that. Because I believe that once we get in here, there'll actually be some interesting graphs and whatnot that we'll be able to access.
Somebody's got to have made compiled Doom for ESP 2080.
So
2866.
probably one of the other big project that this CNLore is known for is running Minecraft servers off of the ESP 8266.
What?
Yep.
But what?
At least as high as version 1.1. So.
What?
Okay, we got some. Hey, comms established. Perfect. We're in. Hacker voice.
Like a full computer has trouble with running a Minecraft server sometimes. How? I don't understand.
I'm unsure. I think it might be a stripped down version of Minecraft. I don't. Truth be told, I don't know Minecraft, but I do know that he's quite proud of it. So yeah, as you can see here, it's just throwing out all sorts of fun.
So what's the graph there?
This here is showing you I believe these are the frequencies that or at least a simulation of the frequencies that are coming out of this thing. Current continued demo, sure. System 3 hertz, 8 hertz, 22. So here we could actually change some of the the information. Why can't... Introduction. Okay, it's only going to give me that. Okay, this should be... This is at least it says it's a discrete Fourier analysis of the frequencies it's outputting. And I'm guessing that, yeah, this combination of 16 and 20 sub-harmonizes into channel 3. System offline.
Is it sending sound as well?
No, unfortunately not. Not this version. Yeah, no, it's still connected. Okay. It is a third party ESP8266, so I think that might cause some of the instability issues, but my understanding is you should be able to upload some custom stuff into here at some point.
To actually have it like show something else?
Wait, no, I'm sorry. I'm getting my two projects mixed up. Yes, this one is as is to start, just as a broadcast. If I wanted to actually change some stuff that it's broadcasting, I'd have to go into the code and actually change that there. But that's all right. The proof of concept is there, and it is something that, yeah.
Yes, as somebody in the chat mentioned, there is licensing regulations around broadcasting.
Yes.
Those are generally denoted by the power level. I'm pretty sure how the power level of this ESP thing is going to be not in the order of however many watts is required.
Yeah, I'm very curious now just to see if I can, within cord distance. Okay, yeah, the minute you get out to here, it starts to...
Oh, there, lost it.
Yeah. Well, you've lost it on screen, too.
Oh,
But yeah, it's, yeah, about here. So that's, what, 6 feet, generously?
Yeah. It's like the CFUV radio station, the UVIX radio station that is quite difficult to pick up if you are outside of UVIC.
But yeah, okay. I'm going to, until I've had some time to stabilize this guy. I think we've just made ourselves a successful little system.
So this is like, because this TV doesn't actually have, does this TV actually have inputs in it, on it?
You know what? Actually does have a composite video and audio. So that's going to be useful later on because we may be doing some, we're going to be doing some more CRT fun today.
Nice.
But yeah, cool. I'm happy with this. This is going to be good for us to play with in future, I think, just for broadcast wise. Let's leave that going while we move on to project number 2, which is
Boom.
what you're all here for, I'm sure. Raw CRTs.
Whoa.
Jung. There's my scan wall. So this is just a Sony cathode ray tube in a vertical orientation because these
Holy
were used
doodle.
for the Watchman series of products, and they're quite the little thing. Got to be careful where I grab this thing too.
Yeah.
Thankfully, the high voltage section is clearly indicated by some angry lines.
I was gonna say, I don't remember. I don't have a whole lot of stuff from my my days in when I was taking information technology and applied systems at school. But where they were teaching us like how to repair computers and things.
Mm-hmm.
But there's a very explicit thing of the inside of a computer monitor and the inside of a computer power supply.
Mm-hmm.
It was like, you are not qualified to go into these.
Yes.
If it's broken, replace it. You do not go into either of these. Because there's some nasty stuff in there. From what I understand, a CRT, the tube on a CRT is effectively a ginormous capacitor.
Yeah, essentially. Like
and
all this down here.
And it can keep a very substantial amount of shocking electricity for weeks
Yes.
afterwards, after it's unplugged.
Yeah, I've seen some of the disturbing tools that you need to use to deal with these things. Get just get a little probe underneath this vacuum port here, and we will not be doing any of that today, because all we are going to be doing is hooking this thing up through the low voltage connection systems. So yes, no actual work on cathode ray tubes, but we are just going to be working with cathode ray tubes. Hence the fun with cathode ray tubes, and not injury with thus.
Yeah, the way they explained it in when I was taking the course was, it was like everything on the computer side of the power supply, like on the inside of the inside of the computer. That's all 5 volts and stuff. The worst you could do there is you can damage the computer, but nothing will hurt you.
Yeah.
On the other side of the power supply, that's where the mains voltage is.
Yeah, you see, well, the main voltage, or just direct current at a high enough voltage or amplitude is going to be, not an amplitude. If it's direct current, there's not going to be any amplitude. What am I even talking about?
So what is a Watchman?
The Watchmans were portable televisions.
Okay.
Yeah, they kept making these sorts of tubes. Not necessarily Sony, but I know that I think Iowa kept making them up to 2007 because they were used in video intercom systems for people with doorbells.
The 90-degree orientation of the tube is amazing. Like, because that's always been the problem with CRTs, is that they have to be so deep. Mm-hmm. So it's almost like a periscope.
Yeah, the problem is that you can see there's a bit of a curve going on there. So the electrons are coming out of the bottom and are hitting the screen at different elevations.
So there has to be a some sort of like anti-keystone thing built into it.
Exactly, and similar with brightness too. But the phosphors should be good and bright, and it's a Sony, so hey.
Neat.
So the someone else has gone ahead and worked with a different model of this. I don't know where they pulled down their. Sorry, let me give some names. Let me name names. Bitlooney is the one who I found about what to do with this. And the answer of what to do with it is, hey, guess what? Remember that I2S to DAC conversion system? You can do that on different microcontrollers in addition to the ESP8266, things with more processing power like the ESP32, something that has somehow the ability to run small games on it. And so he's converted an ESP32 and one of these devices into a CRT-based Game Boy, which looks gorgeous, but...
So so we're not using the DAC for wireless broadcast now. Now we're using it to generate the signal for the CRT.
Yes, using a composite, composite, not component, a composite video signal.
Okay, so we're basically recreating a composite video signal from scratch.
So what this person has done is he's put together a library that will generate the analog signals by doing a line through the I2C, then adding a reset point and a synchronization pulse and then back again. And so it's actually outputting better than even home consoles of the early era, which would do a 240p. This is doing full-on 480i.
Swank.
Yeah.
I've watched a bunch of stuff about old console programming and all this stuff about, like how they can mess around with the vertical blank and the horizontal blank and using it for video games and, stuff, and taking advantage of those.
All that fun stuff.
The weirdness of CRTs.
Yeah. So this is this particular model is something that I picked up during the pandemic. I've got pictures here from the person who initially tracked them down, and they're time-stamped with 2020-12-28. So 28th of December, which I think is about the time I received mine as well. And they were looking at about, I think, $10 a piece off of AliExpress. And I thought, I mean, God, at that price, why not? Even if I'm not able to do anything with it, at least maybe I can make it into a retro computing display of something. And I think we've absolutely been able to.
So is this a new, like this isn't an actual vintage thing? This is a newly manufactured.
This is new old stock.
Nice.
And I don't know if I can see a manufacture date that I recognize on here. Just trying to find any date at all. And I don't see anything that would be printed on after the fact. So unless someone's very good at analyzing numbers and labels, maybe you can get something off of that number there on the actual CRT itself. Oh my, okay. Oh! Hey, you want to know where all that information is, folks? It's behind the black shroud on the back of the screen. So this was serial number 1032, DC 10 volt, 40 watts. So why did they say we can do with... Okay, 12 volts has been tested and is okay for this, which is what we're going to be doing today. Yep, made in China, 04 JMC. So my guess, based on this label here, is that this was either the 10th of November, 94, or the 11th of October, 94. Just based on the way these sorts of serial numbers tend to go.
And looking at this now, it seems like how this is configured is that as opposed to a normal CRT that the electron gun is behind. In this case, like not only is it below, but it's actually hitting the front.
Yes.
Of the screen, like it's hitting the part that you're looking at as opposed to the behind.
You are exactly correct on that. From what
which means that I guess it would mean that the picture is actually reversed compared to what would normally be.
I mean, it would probably be the case if they weren't doing some flipping. Probably
they're probably doing it, internally.
I mean, we're going to find out one way or another.
It's sort of rear projection as opposed to front project, or this is front projection as opposed to rear projection.
Exactly. So we're going to find out one way or another. But before we are able to find out, there we are. Is that it? No, that's not the one I need. This is just my pinouts for right there, Arduino Pro Micro. Our other favorite microcontroller here on the network. Oh my goodness, do I not have the piece of paper for? Aha! There it is. I kept it in the other one. Remember, kids, always buy 2 microcontrollers when you buy them. That way you, I don't know, you have an extra?
Well, and for the majority of these microcontrollers, shipping is the most expensive part.
Usually.
It's like, $2 for the microcontroller and then $15 shipping.
Here we go. So yeah, when I ordered these from our good friends over at universalsolder.ca, not a sponsor, but call me. A couple weeks later, got this note from them saying, "Hey, whomever we ordered, we being Universal Solder, these boards from, the 2 voltage regulators are in the wrong spot. So we're going to need to desolder these 2 gentle friends, and then move them over." And
Have you've checked yours and it is indeed incorrect?
I have, and I am sad about that. But that said, when this is done, I'll be able to use these. And boy, the size of these lads is just nothing. And you can have a camera on a webcam, and all it is this. This is it.
That's you have a little webcam model for it.
Yeah, we're gonna. The idea is that one of these is gonna sit behind the hummingbird feeder, such that when the hummers come, they can. Well, they'll be tagged.
Ooh.
But all right. Oh boy.
I'm imagining it like cuts to a cut to the factory where they're assembling this, and there's a guy assembling who's just completely cross-eyed. Like, I don't see what the problem was.
Who could? Yeah. What's the issue? So, I'm thinking to myself that we are going to give this a try, but boy, this is maybe I should have brought some tweezers. Yeah. Okay. Well, let's see if we can just get in there and wick away some of that solder.
I thought I saw a little pair of tweezers out on the table.
Yeah, I thought we had... we've got the clippers, but I thought we had a set of solder sucker with clippers as well. Oh, well. Yeah, let's see if we can get away with just wicking, because that will probably be the easiest way of doing that. And if that doesn't work, we have a backup plan in the form of a Raspberry Pi. So not to worry. There you are, Braid. Game of the Year award winner, Braid. Useful for sucking solder, and just have to get the... There it is.
Traveling back in time and somewhat heavy-handed metaphors for certain things.
I mean, using a soldering braid is, in its own way, a way of traveling back in time. Time before. I mean, this is surface mount, so this is not going to be the easiest thing to deal with anyway.
Right. Yeah, surface mount soldering is a whole extra thing, isn't it?
Yep. Ooh, boy.
It is about time for a break. Do we want to take a quick commercial break and see if we can find that those?
I think that's a good idea, Paul. Let's take ourselves a short commercial break, and we'll be back with more Tinker Tailor Solder Fry and CRT fun in just a few minutes. Don't go all the way away. Hello, folks. We are back with more Tinker Tailor Solder Fry here in a mighty loading ready run video entertainment network. My name is Ian Horner. I am your navigator through today's activities, and well, we were going to try and move some of the voltage regulators on this ESP32, or sorry, ESP32, one that I haven't played with yet, and I'm very excited to give it a try. But if the minute we plug it in with the voltage regulators backwards, poof. And I don't want any more magic smoke on my watch in the next while. Unfortunately...
I wonder how many of those went poof before they
probably
figured out the problem.
I mean, the fact that they sent out an email says to me that they probably fielded quite a few customer reports on that. No, we were going to give it a try to move the voltage regulators, but in my defense, the picture that they sent along makes these voltage regulators look a lot bigger than they actually are. See if you can tell the difference. So unfortunately, I'm going to have to do, rather than try and ruin it, well, rather than actually ruin it by trying to remove them on air with the tools that we have with us right now, I'm going to instead wait and use the appropriate tool back home, which would be an air rework / camera lens ruining station. And we can appropriately mark off the areas that don't need to be heated with some Kapton tape. We can get it in there and just use some tweezers to just, and hopefully leave some of the solder back on so that we can just go whoop with the hot air and have the things just sink back into place, should they do that.
Now I kind of want somebody to make an like ESP32 that's like 8.5 by 11 inches, like a giant sized ESP30, like a novelty enlarged ESP32.
Well, miniaturization has been a problem for everyone. I would personally love for us to all go back to good, solid, thick, large, through-hole soldering. Makes everyone's life a lot easier. But this won't be the last you see of these, little friends. So let's find out what was on this Raspberry Pi the last time I thought I would use it. I know for a fact that it's not the OS that I used to reflash the BIOS on this laptop, because I have a special card for that. Yeah, that was the time we needed to get, where is the little hooks? I needed to flash the BIOS because I wanted to do some mods to this thing and install a Wi-Fi card that was compatible with macOS rather than just Windows, because this is a Hackintosh. And so needed to get, first of all.
So you're running Mac, Windows, and then Linux in Windows and
subsystem.
and Linux and Mac too, really.
Yep. Ooh, and actually we're going to need these anyway. These are, some of my favorite little doodads. These are probes with an embedded hook or little set of grabbies on them. Ooh. See them little come out there. But those are great because they're great for individually grabbing legs of chips. In case you needed to reflash a chip while it's still on the motherboard.
Cool.
Yeah. So we shan't be using that to flash chips today, but we may need that to hook into. Actually, we probably won't need to. These JST connectors, we can probably just DuPont right into them. Which, hey, if you're willing to make it easy for me, I'm not going to complain.
There's a lot of situations where probe with grabbies would be a very, very distressing thing.
Yes. I did forget one thing, and hopefully you can help me out with this, Paul. I'm going to need a RCA cable.
Ooh. Kicking it old school.
Yeah. And,
1 sec.
Yes, I realize that might not actually be the easiest request immediately. While we're doing that, I'm just going to prepare the Raspberry Pi here. We got a keyboard and mouse. This, for those curious, I believe, is a Raspberry Pi Model B. Got these a long time ago when I was trying to spec something out for an old job to do some homebrewed digital displays in shop.
Just video or the triple?
Just the one. Yeah, one is all we'll need right now. Perfect. That was easy.
Yes.
Great. I'm going to... Heck. This is a technology stream. We might as well rock it with the top off. Okay, so for the moment, I think what we're going to do is we're just going to, we'll just let the analog...
I like we're very slowly moving forward through time.
I don't know.
Analog broadcast to RCA.
If I had the ability to broadcast to my TV over the course of 4 meters back in the day as a kid, like you used to be able to do with those microphones for the FM radio or the AM radio, God, that would have been a big game changer, especially for consoles.
That's true.
No more trying to get back behind the TV. Because remember, that was back in the 80s and early 90s when everyone had those horrible, huge wood entertainment centers where the TVs would slot in and you'd have to reach back behind and try and remember where all the things were.
That feel of reaching behind, not only reaching behind, but trying to screw in the F connector.
Oh God, yes. Because you can't take it out because it's too heavy to take out of the cabinet. All right, we're gonna have to power you down to give power to our Pi. So let's do that now. Goodbye, television. Internet killed the television star, quite literally at this point. There we go. Okay. Come on, little TV.
There might be a setting you have to do to make it see its RCA.
Very good point.
There's a bunch of switches on the bottom there.
Yeah, TV, AV. It's not for those. But we are getting, well, you're not seeing it because all you're seeing is the refresh rate, but it is at least a solid black signal for me. Is that the case even when I remove the video? Yeah, it is. Okay, so that doesn't tell us anything. Something's definitely happening. The act is flashing a lot. And it continues to flash. All right, 1 second. We're just going to power this down and have a look at the card itself to see what... I know there's some things that need to set, or you used to need to set on a Raspberry Pi to get it to display, right? Right? Okay. So it gave us 2 different. I see what's happening here.
There we go. There's a button on the back to switch it between TV and AV.
And I had already hit that.
Oh, you did?
Yeah. So now you've got it back to TV.
Oh, okay.
That's all right, though.
Oh, I see. Okay, yeah, that switches it there.
Oh my goodness. Boot code, CMD line. There we go, CMD line and config.txt. There we go. Overscan. We have composite. Uncomment if HDMI display is not detected and composite is being output. HDMI force hot plug.
I'm kind of loving this idea of a supersized microcontroller.
Like
make the PCB out of, like, you know, 1/4-inch MDF.
So I do know that for a lot of these microcontrollers, they do make a breakout board at least.
Right. Yeah.
That is extra oversized and has all the holes and the pins pre-soldered onto it. But just bringing out my old USB cards to see if maybe we can.
So you think the issue is that flash card is not set up correctly?
I think that's the case, yeah. The issue being that my what's the best way to put that? This was set up to work specifically with HDMI monitors in a sideways configuration.
Ah.
Yeah.
I mean, should we just bring in an HDMI monitor?
We're going to try one more thing, and if that doesn't work, then the answer will be yes. Let's see.
If I recall from other things that we've done with things, the Raspberry Pi is a little wonky on vertically oriented monitors.
Oh, here we go!
Hey!
We have a display, and we have perfect. That's all we need. Okay, so you know what? We can just unplug that now because we know it will boot properly. And we know that it is sending proper NTSC signals. So for the moment, I'll just plug this back in and go to TV. Just so you can all watch something fun while things happen. Button. There you are. All right. Next up, we're going to need to find a way of connecting this to this. And blissfully, the person who did initially advertise where to get these things was nice enough to do the work for the pinouts. So we're going to need a few things here, starting with, I'm just going to, yes. That's why we need to turn the TV off, because I need my 12-volt power supply. Now I have a 12-volt power supply. And in my pocket, I think I've got, yes I do. Here we are. A little barrel connector to some terminals. And let's get out a punch
I'd like to think
board.
that you just have that in your pocket all the time.
Yes, ready to moment's notice. And let's get some wires out for the fun. I say that with such confidence, don't I? That this is going to be fun.
I believe you.
I appreciate that. I hope that I can just jam these in here. Nope, I can't. One second, please. I know what I need, and I will be right back for it.
Ian will be back. So let me just hear the tip, 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 slam. Vroom.
Thankfully, taking an inventory of your tools during a break lets you know exactly what you have on hand. Tiny screwdrivers.
Oh no. The tiniest of screwdrivers. Each more tiny than the last.
So, I remembered something at the last minute here. If you are going to use screw-down terminals like this, and you want to loosen them, I would highly recommend that you unplug it from the live power supply before you touch metal to metal.
Especially by using a screwdriver with a metal handle.
Exactly. Like I said, remembered it. Just needed to pass that along to those of you who maybe don't. All right, now we have our power set up here. And let's just get them on the rails. Blink, blonk. Okay. Now, let's start by giving this thing power and seeing what happens. Let's just toss that out of the way here so we can bring this front and center. Actually, I'm going to turn that around for your enjoyment, and also so that the high voltage stuff is away from me rather than in touching distance. Okay, next up, I need some of those Proby boys. I make sure to always use the appropriate technical terms here, because otherwise people could get confused.
Proby boys.
We may actually be doing some quick manufacturing here too. Okay, yeah, alligator clips I think are what I want for this particular one. So let's get those clips and, oh, yep, let's put some new ends on those. Those are pretty ugly. These are pretty ugly looking here. I hope you would agree. We don't need to do all of them, but we do need the 2 of them at least. Because these are especially good for connecting to RCA in such a way that you don't cross the streams. Not sure if that's visible there, but we'll get there. So, time to break out the crimpology.
Right, I guess. So RCA, I mean, it's it's one of those things. As a person who's worked with AV tech for most of my life, I don't actually know how RCA. I mean, it's just one of these, like the center. The center part is isolated from the sleeve part, so it's sort of like it's like a TRS jack, except it's in the prong in the middle and in the sleeve on the outside, rather than 2 parts of the same.
Exactly. Right. This is trying to remember how far I need to go, how deep I need to go for a DuPont crimp, and it's not that far. Okay, let's spin those around a bit, twist them up, and what do you think? Pins? I think pins rather than holes. Let's get a couple pins out.
The DuPont company would like to warn you against crimping too greedily and too deep.
The DuPont company holds no power here. I hold allegiance only to Dow. Actually, fun fact, a small internship at Dow Chemical in Fort Saskatchewan, Alberta, was actually my first job. It's part of a Shad Valley internship, and
Shad Valley?
Shad Valley is it's a Canadian, I think it's, no, it might be international, but I know it's at least Canadian, and they're sort of a science, technology, and entrepreneurship incubation program, summer camp for kids who are just getting out of high school and going into university.
Oh, neat.
It's a fun little program. I've become far less enamored with I mean, let's just be honest, capitalism since then. But if that's your bag, it's a really good place to network and learn and make some new friends. And they've got campuses all across. Well, they're on university campuses in the summer, all across the country.
I mean, sort of, even if it's run by some large Dow Chemical company, something that is, teaching kids skills in terms of, electronics and engineering and stuff. I think that's something that can be a positive thing.
I don't think that's bad at all. And actually, it wasn't even sponsored directly by Dow Chemical. It was Dow Chemical is just one of the partners. The idea is that you were, as part of it, you are out to go out and find your own internship, and that was one of the places I was able to find in my hometown. that's, I think, how you do it. We're going to have to check the continuity after it gets pushed through here, but just want to make sure we can get that, into the slot first. I don't know what you're talking about. You can absolutely use crimper or side cutters as pliers if needed. Okay, there we go. Just have to trust the process, like so many things. Shove it in. Crimp it down.
Like so many things, you just trust the process and shove it in.
Yep. If it fits, great. If not, apply gentle pressure. If still not, apply repetitive, percussive, gentle pressure. Hey, there we go. Let's make sure those are doing what they're supposed to, which is conduct electricity from one end to the other. You do, and so do you. Great. Ideally, that's the last we'll need of that. Okay, so now we can connect things up. In fact, actually, I don't even think we need the board, TBH. Right, pins. Which pins are we connecting to? My thing says pin 1, composite video in, brown wire. Okay, so let's go with video in is going to be pin, I believe, because the ground is the outer edge. So let's go signal is red, and ground is black. Okay, let's make sure there's no bridging there, because that's always important. Up, you are power. No bridging. No bridging here. Good. And that would be bridging if those were touching. Perfect. Center pin goes to Browntown on the CRT. Okay, that just goes in there, I guess. Let's make, again, sure that it's making a positive connection. Okay. U to U. Perfect. Okay. And pins 2 and 3 are ground for video and power. Okay, great.
So that what you're plugging into the CRT there is it's not like the CRT is expecting an RCA signal or any other kind of signal. It's just raw analog voltage on those pins.
Yeah, well that'll be the raw RCA or composite video voltage, and then it'll be 24 volts on the other bus to the
is the CRT now going to show what the other thing was showing, like the actual output from the
Raspberry Pi?
For like just the as if it was a monitor that's plugged in?
Yep.
Oh, okay.
Yep.
Cool.
This is essentially an RCA jack, just not as an RCA, not in the form of a jack.
It's a deconstructed RCA jack.
So we've got ourselves some good grounding there, and let's put the power in as well. That's the final one. And then pins 4, pin 4 is power, so we should actually, that's right. Okay.
Wait, so why is there more than, if an RCA jack is only 2, why is there more than 2 going in there?
Why are there more than 2? Because this is a connector for everything. You're getting the 2 for the RCA jack in pins 1 and 2. They share a common ground, but they have 2 pins for that common ground. So we've got signal going into pin 1, the brown cord. We've got ground for the RCA going to the first common ground. We've got the second common ground coming out to the ground on our power. And then finally pin 4 is the acceptance pin for the 12 volts.
And that's actually going to power the CRT.
Exactly.
Cool.
5, 6, and 7 apparently can go to a brightness pot, with 6 being the wiper in the middle of the pot.
Ooh, neat. But without that, I guess we just can't control the brightness.
Mm-hmm. And they say sometimes it can require a 50K pot, a potentiometer, and I don't have one of those, unfortunately. So if that causes an issue, we'll run into it quickly. That said, are we game to plug this in?
All right.
I am. Okay, we're going to plug it in without powering the Raspberry Pi first, just to see if anything funny goes on here. And actually, I'm just going to...
So this is just seeing whether we're sending 12 volts. We're just going to see whether sending 12 volts into the CRT causes any issues.
Exactly. Just make sure it powers on. And for that, I'm going to take the barest amount of protection, just in case this thing explodes on me. Okay.
Should we be seeing anything?
Maybe not. I'm just going to double check that we are getting the right voltage here. That's 12 volts DC. Yep, that's good. Black. Okay, it is giving us 12 voltage. It might be in the wrong orientation, so I'm going to just swap the polarity on the power. I'm just going to inverse polarity here. Let's see if that helps us out. And plug it in. I don't like the sound that made.
Uh-oh.
Let's go back to the other side, but oh no.
The fact that it made a sound is indication of something.
Yep. I think we may have done a bad there.
Oh no. I don't see any smoke.
I do smell some smoke, though. What's going on underneath here? Oh no, that's a bad smell.
Oh no.
Well, let's see what happens if we plug it in again. Just make sure that it's giving us the right voltage. It's still giving us the right voltage. Shall we try turning on the power PC, the Raspberry Pi? Let's do it.
You should definitely be seeing something.
Yeah. I think I made a heck up there.
Oh no.
Boo! Well, I'm not out a lot of money, but it'd be nice to know what I fried.
Now, I remember when you pulled the back off the thing, it did say 10 watts, didn't it? And then you were like, but the
It
thing...
does. But as I said,
this thing says 12 is fine.
Yeah, this person has absolutely gone 12 volts on it, so...
Is the polarity being swapped could have been an issue, or?
Normally not that bad, but yeah, if it's going in a different way than it's expecting, and it's not, and it's direct current, yeah, that could be if it's not dioded, then bleh. Because it's not smoke. There is no magic smoke showing, but there is definitely magic smoke smelling right now.
Now, theoretically, it's that something on the controller, like the actual CRT itself, is fine.
More than likely, yeah. And honestly, who knows? This honestly could have just been a bad board to begin with, because I haven't powered it on myself before either. I'm just trying to trace here where we could find out if there's a safe place to
See if there's anything.
probe.
Do you see anything like burned on the board or anything?
Nothing in particular stands out. But if I had to guess, it's probably going to be something on this chip here. LA7806. What kind of chip is that? 7806.
It's a smoke chip. Why do we even have this chip?
Incorporates various functions required.
Oh, good. Oh, good.
It's a it's a black and white TV synchronization deflection chip. Multifunctional integrated circuit that is based on the internal circuit of the LA7800, incorporates various functions required for synchronization and deflection circuits of monochromatic television sets and operates on line voltage or from battery. And that, you know what? That sounds like the kind of thing that would, if it's operating on line voltage, being an issue. Let me see what it can take. No, it doesn't give me the full data set. Well.
I do like it's a chip that's responsible for various functions.
Yes, various functions. Bah. Well,
I guess there's no way to sort of test whether the thing will even power on anymore without all the Raspberry Pi stuff. But I mean, that's what you were doing anyway.
Yeah, I mean, we can make sure that the Raspberry Pi isn't at fault here by plugging the TV back in. That should be an easy something, at least.
There aren't any lights on the board of the
No.
thing to sort of indicate if it's actually running or not.
Unfortunately not.
I guess that makes sense. It's like I guess when you're dealing with a CRT like that, if they had LEDs to show the status of it, they could just be using LEDs.
Yeah, that would be a lot easier. Yeah, no, it looks like it is, in fact, the Raspberry Pi is still sending video just fine. Actually, just because I'm curious, I want to make sure that we got those plugged in correctly as well. So let's just yank those out. And let's see here, we wanted center to center and out to out. And let's just see what happens if I twiddle this way. Can I just touch them? Okay, yeah, so these are, in fact, the cables are working too. So it's just that, well, you know what, let's give it power. Plug these back in and double check one last time.
You know that it was indeed sending 12 volts because you were looking at the thing.
Yep, we tested that right off the wires here. Okay, give me power once again. Little percussive maintenance, sometimes that'll help. Let's double check again to make sure that it is getting that power. Yep, 12 volts are being supplied. And on the board as well. Welp. I am unfortunately not a repair technician. Unless that 50K pot is absolutely necessary to bridge those terminals and control the brightness. But I don't. It's hard to say at this point, again, because we don't have a known good state to go to. Boo.
Boo indeed.
Yeah. Well,
So it's a problem. I mean, this was sort of the thing I was worried about with that TV, where it was like, we don't know whether the TV worked. So, like, the TV wasn't necessarily a known good state. So it was like, there's a bunch of other stuff that we didn't know whether it was going to work. Also, it could be just the TV doesn't work.
At least we fixed that the first time.
That's true. That's true.
Yeah. Let me see here.
It's like I always remember in was it The Right Stuff, the thing about the initial moon or NASA test flights. They get a warning light on the dash in mission control, and the first thing they do is call up their counterparts in Australia, because there's two. They have a exact copy of the whole setup on the other side of the world to match, and check whether they also are getting a warning light, or whether it's just the bulb that's messed up.
Yes. Is this actually faulty or not? Interestingly, while we're on the topic of the moon and networking technologies, I was rather surprised to see that apparently NASA is bringing back optical tight beam communication for the next Artemis mission.
Ooh,
which
like
mean,
lasers?
Yes, specifically UV lasers. And
Cool.
they've got 2 receiving stations, both of which are in America, which I found odd, because I remember back in the day, the first Apollo missions, they had that listening centers in Australia, and I think they had one in Europe as well.
Are there satellites that can receive that as well?
That's a good question. I'm not
And like
sure.
relay it?
It would make sense to do that, because you wouldn't want a laser signal having to pass through the atmosphere in order to get the thing. That said, the bandwidth of this network system will be such that they'll be able to send 4K video back to Earth.
Whoa.
Which means that we will be getting some amazing shots of the moon when this next mission happens. But
I sometimes have trouble getting 4K video down an HDMI cable, like 20 feet.
well, I mean, maybe it's time for you to stop buying monster cables and start buying monster UV lasers.
Apparently so. Apparently so.
Yeah. All right. Well, I know I don't honestly think there's anything more we can do with the parts and tools we have with this at the moment, so
The fun is over.
yeah, I guess this is just going to be an early one. I flew too close to the sun this time. And that's, I guess, going to be it for Tinker, Tailor, Solder, Fry for the night. Thanks so much, everyone, for watching. Thank you for all your support in the chat, helping us out with what we do here. And, of course, thank you to those of you over at patreon.com, once again, /loadingreadyrun, for keeping the lights on here. It's been an absolute pleasure having you with us. We will see you in a fortnight's time. Never in Fortnite, though. It's my own personal choice. Ever forward, learning out of spite. Good night, everyone.